Every rule for differentiation must have a corresponding rule for anti-differentiation. For example, if we wanted to evaluate the derivative of y is equal to g of x raised to the power n, we would use the power rule with the chain rule. So when we take our derivative, y prime, we would evaluate with the power rule first. The n would come down in front. The stuff on the inside would stay exactly the same, now raised to the new power of n minus 1. The chain rule would then say I had to multiply times the derivative of the inside function. So I'd multiply by g prime of x. We previously used the convention to rewrite g of x as u. So if I have y is equal to u raised to the n, where u is some function of x, when I take the derivative y prime, I would have n times u to the n minus 1, and the chain rule says I would have to multiply times the derivative of u in terms of x. Let's consider the antiderivative rule that reverses this action. Our next theorem is the generalized power rule. If we let g of x be a differentiable function and n be a real number such that n is not equal to -1, then the integral of g of x raised to the n times g prime of x dx will be equal to g of x raised to the n plus 1 divided by n plus 1 plus c. This is easier to understand if we use our previous convention of letting u be equal to g of x. So for this example, say we have u is equal to g of x. So the derivative of u, du, will be equal to g prime of x dx. We can rewrite our integral as the integral of u raised to the n. Notice that the g prime of x dx is exactly now our du. We use the power rule for antiderivatives to get u raised to the n plus 1 divided by n plus 1 plus c, and then we substitute back for u to get g of x raised to the n plus 1 divided by n plus 1 plus c.